Hello dear students, I'm back again with another video. Listen, in a previous lesson, if you remember, we stopped here in a transformer, and in a previous lesson we discussed and you have learned about the oscillating circuit and the electric resonance. Oscillating circuit is the oscillation of the electric field, is the oscillation between the inductance and the capacitance. Okay, so when and the resonance is a phenomenon that occurs when the frequency of a given source, AC source, enters a circuit that has inductance and capacitance. So in this case, when the two frequencies are matched to each other, so the resonance will take its place. And we stop it here in the transformer. Transformer, what is transformer? Is a device that changes the potential difference of alternating current, either increasing potential difference, which is called a step-up transformer, and decreasing potential difference, which is called the step-down transformer. Transformer is a very important device in our daily life. It has many uses and many applications. Like, for example, in a power transmission, we are using the transformer. For the power transmission, we have to use step-up transformer in order to reduce the power dissipation and to get the efficient transmission of the electricity. And also, the transformer can be used to reduce or decreasing the potential difference to save use, like in our city, to reducing the huge potential difference when it reaches the city and the factories to appropriate amount of the potential difference. And also it has many applications like for the chargers and many other electrical devices, such as a microwave can be used. The transformer can be used in a microwave to increasing the potential difference, because microwave oven requires more potential difference. Okay, you know that in the outlet potential difference at our home is about 240 volts. Okay, this 240 volt is not enough in order to working the microwave oven. The microwave oven requires 2000 volts. Okay, so that is why we have to use step-up transformer. For the chargers also, transformer is very, very important, because you know that our electrical devices such as a mobile phone and the laptop or computer, they require like 5 volt or 10 volts. Okay, how can we get this 5 volt or 7 volt or 10 volts when the outlet potential difference is 240 volt? By using step-down transformer. Each charger has transformer. The transformer of the chargers is step-down transformer. They decreasing the potential difference from 240 volt to 5 volt or 10 volt. It depends on the device. Okay, and the definition of transformer, guys, a device that increases or decreases the EMF or potential difference or voltage of alternating current, AC current. Transformer is working only with the AC and DC pulsating current. Okay, and the transformer using the principle of electromagnetic induction, because the current is induced in the secondary coil. In transformer, the current also increases and decreases together, because power is constant. Okay, power is equal to what? Power is equal to the amount of the current times the potential difference. P is equal to what? Power is equal to IV. When we increase the potential difference by using step-up transformer, what happened to the current? The current decreases, but power constant. Okay, so the step-up transformer cannot increase the power. Step-down transformer cannot reduce or decrease power. Power is constant. Okay, because power is constant, so current with the potential difference is inversely related. When potential difference increases, the amount of current decreases. When potential difference decreases, current increases. In its simplest form of the transformer, an AC transformer consists of 2 coils. How many coils? 2 coils. Okay, and of wire wound around the core of a soft iron-like apparatus of the Faraday's experiment. AC current and DC pulsating current would work with the transformer. Transformer with DC battery does not work, because flux doesn't change, magnetic field doesn't change in DC current, in DC battery. So that is why in transformer we need change in magnetic field, change current or change flux. Without change flux, there will be no induced current in the secondary coil. Transformer consists of what? An iron core Look. This is input. Okay. I1, V1, P1. Okay. Input power. The wire is wound around the primary coil. Okay. And in the secondary coil, this is number of turn in primary coil, N1. We have V1, N1, I1, and P input. This is input. Okay, input power. In the output, guys, look. Like we have resistance, this is number of turn in the secondary coil, N2, and this is I2, V2, and output power. This is input power, this is output power. Okay, and this is the iron core. What is the advantage of iron core? Iron core guides the magnetic field line from the primary coil to the secondary coil. The iron core guides the magnetic field line from the primary coil, guides from primary to what? To the secondary coil. Okay, so because of the iron core, the dissipation of the magnetic field is less. Okay, so we don't have more dissipation of the field lines. Mostly of the lines passes between the two turns, okay, and the two coils. The DC produced by the battery would not work with the transformer because we don't have a change in magnetic field. This source must be AC or DC pulsating, guys. Transformer does not work with DC battery. Why? Because in DC battery, current doesn't change. When current doesn't change, when current is constant, magnetic field also constant. When magnetic field constant, flux is constant. If flux is constant, change flux becomes zero, and induced EMF zero, induced current is also zero in the secondary coil. But guys, in AC source, the value of current, it is magnetic and direction changes continuously. When current changes, what happened to the magnetic field? When current increases, magnetic field also increases. Flux changes and EMF induces. In AC current, the magnitude of the current changes continuously. This change of current, it goes to change what? Change magnetic field. Okay? When the magnetic field changes, magnetic flux also changes. Guys, look. So the magnetic field induced in the coil by this current. Because the current in AC is alternating current, magnetic and direction changes continuously, so that is why this field also changes continuously. So some of the magnetic field line passes through the secondary coil. Okay? If the number of, guys, flux per unit of time changes in the primary coil, also flux per unit of time changes in the secondary coil. Okay? When the magnetic field changes in the primary coil, in the secondary coil also magnetic field changes. When the magnetic field changes, flux changes and EMF induced with the current. So V2 and I2 induced because of the change in the magnetic flux. So the equation of transformer is equal to V1 over V2 is equal to N1 over N2. Now I'm going to prove these equations. Guys, E1 is equal to what? Negative N1 flux per unit of time. And instead of epsilon, can we write down V's? Because both of them is measured potential difference. Okay? V2 is equal to what? Negative N2 flux 2 time. Okay? This two change flux in primary circuit is equal to, guys, change flux in primary circuit is equal to change flux in secondary circuit? Yes. Why? Because when magnetic field increases in primary circuit, what happened to the magnetic field in the secondary circuit also increases. When magnetic field decreases in primary coil, what happened to the magnetic field in the secondary coil? Also decreases. So the time rate of the changing flux is equal between the primary circuit and the secondary circuit, yes. In transformer, the time rate of changing magnetic flux from primary circuit is equal to the time rate of the changing flux in the secondary coil. Look, guys, V1 over V2 is equal to what? V1, negative N1, flux in a primary, time rate of the change flux in primary circuit, negative N2, time rate changing flux in the secondary coil. These two, time rate of change flux, they cancel each other. Negative with negative cancel. What does remain? Guys, look, what does remain in this side? V1 over V2, N1 over N2. What is this? This is the equation of transformer in order to determine V1, V2, N1, N2. What is V1? V1 is potential difference in a primary circuit input. V2, potential difference in the secondary circuit. N1, number of turn in primary circuit. N2, number of turn in the secondary circuit. And also, you can write down like this, V2 over V1, N2 over N1. V2 N1, V1 N2, all the same. They have the same meaning. Okay? You can express the transformer equation in many different ways. Okay? A transformer uses alternating current, only AC and DC pulsating current. What are the main components of transformer? Primary coil, N1 is connected with the V1, secondary coil N2, which is connected with the resistance, and V2, and iron core. What is the uses of iron core, advantage of iron core? The iron core guides the magnetic field line so that nearly all of the field line passes through of the coils. What does the transformer principal operation based on? Electromagnetic induction. Why? Because in transformer, the current and potential difference induced in the secondary coil by changing flux in the primary coil. So these are the equations of the transformer. I proved this equation now. Okay. Conversion ratio. What is conversion ratio? The ratio between N2 over N2, N2 over N1, sorry. N2 over N1 is called what? Conversion ratio. If the question asks us to find conversion ratio, you have to use this relation, N2 over N1. What is conversion ratio, N2 over N1? The ratio between number of turn in secondary to the number of turn in the primary, which is equal to V2 over V1. What is the difference between step up and step down transformer, guys? We have two different types of transformer. Step up, step down. Step up transformer, step down transformer. In step up transformer, guys, V2 bigger than V1. N2 bigger than N1 always. When we say V2 bigger than V1, also can we say V2 over V1 bigger than 1? N2 over N1 also bigger than 1. But current is inversely related. In step-up transformer, what happened to the potential difference? Increases. How about current? Decreases. But power, constant. When V2 is bigger than V1, I2 should be less than I1. So I2 over I1 is less than 1. Okay? So the conversion ratio bigger than 1. But for step-down transformer, exactly opposite of the step-up transformer. V2 less than V1. N2 less than N1. But I2 bigger than I1. Why? Because in step-down transformer, power is equal to IV. In step-down, what happened to the potential difference in step-down transformer? Potential difference decreases. But current increases in order to constant power, because the power is constant. and V2 over V1 is less than 1. Okay. In step-up transformer, convert low voltage to high voltage, high current to low current, but power stay unchanged. Idle transformer. In both cases, power doesn't change. An increase in induced EMF that's in the secondary coil. V2 means that there must be a proportional decreasing of the current because power is constant. In reality, the output power will be less than the input power. In real transformer, P input always bigger than P output. In real transformer, in what? Why? Because the input power is always bigger than output power. For example, assume that P input, for example, 100 watt. P output is equal to what? About 95 watt, for example. What happened to the 5 watt? The 5 watt dissipated in the transformer. The 5 watt dissipated in primary circuit or in the secondary? In both. Okay? In the real transformer, input power always bigger than the output power. Why? Because in the output power, some power dissipated in the iron rod, iron core, primary circuit, secondary circuit, because of the eddy current, because of some of the current when passes through the primary coil and the secondary coil, some of the current transformed into the thermal energy. Some of the electrical energy is converted to the thermal energy, and because of the eddy current and magnetic hysteresis, there are a lot of reasons that goes to the dissipation of power in the transformer. The power dissipated in the transformer because of the coil, the wire. Okay, it goes to the heat or warm the wire, and in the iron rod because of the magnetic hysteresis, and sometimes because of the eddy current, some of the electrical energy is converted and some of the power dissipated. Okay? Input. But in ideal transformer, P input is equal to P output. Flux through the multiple loop is equal to the flux through one loop times the number of loops. If one loop has an area, two loops with A plus A. Okay? So you have to keep in your mind that the number of turns in the coil and EMF directly proportional. If the number of turns in the secondary coil is greater than number of coil in the secondary coil greater than in the primary coil, induced EMF will be greater. V2 will be greater than V1. Okay? When does the transformer become step up? If conversion ratio is bigger than 1. Step down, less than 1. What is the difference between step? We studied. Okay, we did this question. Does step-up transformer increase power? No. Because in step-up transformer is equal to P is equal to IV. In step-up transformer, what happened to the potential difference? Increases. Current decreased, but power constant. Power doesn't change. But in real transformer, some of the power dissipated, but this is not related with this equation. Okay? No, the change in potential difference in transformer is accompanied by an inverse change in the current. In ideal transformer, power is unchanged as expected from energy conservation. In many transformers, the wire around one winding is thicker Look, the wire of one winding is thicker and therefore has lower resistance. Thick wire has low resistance, guys, be careful. Because resistance is inversely proportional to the area of the wire and the cross-section area of the wire. When the cross-section of the wire is more, thick wire has less resistance. Thin wire has more resistance. And resistance is also directly proportional to the distance. More distance of the wire has more resistance. But with area is inverse. If the thicker wire is wrapped around the secondary winding, a thick wire is wrapped around the secondary winding. Look, this is thick wire. Okay. Thick wire is wrapped in the secondary circuit. This is N2. Okay. How many turns do we have? 1, 2, 3, 4. and the thin wire in the primary circuit, thin wire around the same, when is the device step up or step down? Look. N1. Guys, which one is bigger number of turns? N1, 3 turns. N2, 3 turns. Which one is bigger? Neither. They are the same. N1 is equal to N2? Yes. So by the thickness and the thinness of the wire, it doesn't matter which wind is thicker and which wind is thinner according, based on this book. It doesn't matter how the thick and the thin the wire rounded around the transformer. We cannot determine by the thickness and the thinness of the wire whether the transformer is step up or step down. Only by difference in number of turns we can determine the step up and step down transformer. So in this question you can answer like this: we cannot determine the type of the transformer because both coils, they have the same number of turns. But in reality, this question has another answer. Okay, in reality, this transformer can be like in the secondary coil, because thick wire is very thick. So the thick wire has less resistance. Less resistance has more current. More current has less potential difference. It becomes step down. Okay, but based on this book, the type of transformer, you can delete the first answer. The type of transformer cannot be determined because the type of transformer depends on the ratio, number of turn. Okay, when N2 over N1 bigger than 1 is it's step up, when it's less than 1 it's step down. But in this case, N2 over N1 is equal to 1. Not bigger than 1, not smaller than 1. So that is why the final answer, we cannot determine by the thickness and the thinness of the wire the transformer step up or step down. Only by difference in number of turns we can determine the type of the transformer. Would transformer work with pulsating direct current? What do you mean by pulsating direct current? Only the magnetic changes. Yes, of course. Why? Because we need change magnetic field, changing current. It doesn't matter the direction or magnetic changes. Okay? Yes, so transformer work with the DC pulsating current because current changes in DC pulsating current. Okay? Outlet potential difference, it means that V1. Outlet current, I1. Outlet number of turns, N1. If the question says potential difference needed, it means that V2. Current needed, I2. But output potential difference is equal to V2. Is what? V2. So this is the step difference between step up and step down transformer in this table. Okay. The questions are very easy in transformer. The step up transformer is used on a 120 volt line to provide potential difference of 2400. This is V1 and this is V2. Because V2 is bigger than V1, the type of this transformer is step up. Primary coil has 75 turns. This is N1. How many turns must the secondary have? V1 over V2, N1 over N2. N2 is unknown. N2 is equal to what? And you can replace number. V1 120, V2 2400, N1 75, N2 unknown. N2 is equal to what? Cross product? 75 times 2400 divided by 120, which is equal to 1500 turns. Very easy. Step up transformer used in automobile has a potential difference across the primary V1 12 volts and potential difference in the secondary 2 times 10 to the power 4. V2 is equal to what? 20,000 volts. Okay. Number of turn in the primary N1. What is number of turn in the secondary? The same. The same question as sample problem we solve. It's very easy, just you have to write down the equation. After that, replace, you can determine the unknown variable. Potential difference of 0.75 is needed. Guys, as I told you, if the question says potential difference is needed, it means that V2. What is this? What is this 0.075? This is V2. This is V2. Provide a large current for arc welding. If the potential difference across the primary of the step down transformer, this is primary V1, 117. What is the ratio? Guys, be careful. What is the ratio? Make a fraction here. Ratio of what? Number of turn of wire on the primary, yani N1, to the secondary over N2. What is unknown? N1 over N2 is unknown. Guys, look. N1 over N2 is not equal to V1 over V2. Yes. Replace. V1 117. V2 0.75. N1 over N2 is equal to what? Is equal to 156 over 1. This is the ratio for the number of turn in the primary to the secondary. Question 35 from chapter review and reanalysis. Transformer is used to convert 120 volt to 9 volt. This is step down V1, V2, and V1 and V2. And a portable CD player is the primary, which is connected to the outlet. What do you mean by outlet? Secondary. Sorry, primary, sorry. Outlet, it means that N1 or V1 or I1. This is outlet has 640. Outlet, it means that N1. Outlet number of turn, it means that N1. Outlet potential difference, V1. Outlet current, I1. Okay? But output, it means that secondary coil. Okay? How many turns does the secondary have? N2. N2 is unknown. N1 over N2, V1 over V2. You can find it. It's very easy. Question 36. 9 volt player has a transformer for converting current in Great Britain. If the ratio of the turns of the wire in the primaries to the secondary, so N1 over N2 is given is equal to what? 24.6 over 1. What is the outlet potential difference? Outlet potential difference, it means that V1 is unknown. V1 unknown. V2 9 volt. How did we know this is V2? Because the question asked it to find what? Outlet potential difference. Outlet potential difference, it means that V1. This is not output. This is outlet. If the outlet potential difference V1 is unknown, it means that this 9 volt is what? Is V2. V1 over V2, N1 over N2. V1 unknown, V2 9, 24.6 over 1. V1 is equal to what? 9 times 24.6, which is equal to 221 volt. Transformer is used to convert V1, V2. This is number of turn in primary. You can find number of turn in the secondary coil easily. Okay. Question 38. Very good question, guys. Be careful. Question 38. The transformer shown in the figure below is constructed so that the coil on the left has 20 times as many turns of the wire as the coil on the right does. The right coil in this figure has 3 turns. The left coil 20 times right coil. If the right coil is 3 turns, 20 times 3, 60 turns. We have 60 turns in the left coil. If the input, so guys, what is the type of this transformer? Can we determine this transformer is step up or step down? No, we cannot determine the type of the transformer in this figure. Why? Because we don't know which side is the input. Without input, we cannot find the type of the transformer. In order to determine the type of the transformer, you have to know which side is the input. Okay, which side is the input potential difference and which side is the output potential difference. Okay, this transformer, if the input potential difference from left to right, it's gonna be step down, but from right to left, it's gonna be step up. If the input potential difference is across the coil on the left, okay, if the input is on the left, now we know that the input potential difference is across the left. If this side is input, this side becomes what? Output. Now, here is input, N1, N2. Because N1 is bigger than N2, that is why the type of the transformer becomes step down. Okay? If the input potential difference across the left, the type of the transformer becomes step down. But if the input potential difference across the right side, the type of the transformer becomes step up transformer. What is the type of transformer if the potential difference across the coil on the left? Step down. It becomes what? Step down transformer. If the input potential difference V1 is equal to 24,000, what is the output? It's very easy. You can find by the equation of the transformer. The last question, potential difference in the lines that carry electric power to home is typically 20 kilovolt. Convert to volt, multiply 10 power 3 or thousands. What is the ratio of the turn in the primary? N1 over N2. If the output potential difference, what do you mean by output? This is not output, output V2. What is unknown? N1 over N2 is unknown. This becomes V1 and this potential becomes V2. So that's all for today. Inshallah, in the next lesson, we will start from the real transformer are not perfectly efficient, and we will study the electric transmission. Thank you for listening.